Welcome. You have found your way to this quiet space at the end of the day. Let yourself settle. Let the weight of whatever came before begin to fade. Tonight, we are travelling to the Mongolian steppe. For much of the year, this landscape is one of the coldest inhabited places on Earth. Temperatures fall to 40 degrees below zero. Wind moves without obstacle across grassland that stretches beyond sight. Darkness comes early and stays long. In this environment, nomadic families have lived for thousands of years. They sleep through winter nights inside circular felt dwellings called yurts. These structures are portable, modest in size, and built entirely from materials found on the land. How does a family stay warm enough to sleep when the air outside can freeze exposed skin in minutes? How do they rest deeply enough to rise again and tend their herds the next day? The answer is not a single innovation. It is a system, refined slowly across generations. It is geometry and material, routine and fire, the arrangement of bodies and the careful management of fuel. Over the next while, we will move through one winter night inside a yurt. We will see how it is prepared as the temperature drops, how warmth is held through the darkness, and how sleep becomes possible in a place that seems designed to resist all human comfort. So settle in. Let the story unfold slowly. The Mongolian steppe is a high plateau. It sits between Siberia to the north and the deserts of Central Asia to the south. Most of it lies above 1,000 meters in elevation. There are no natural windbreaks, no forests, no mountain ranges close enough to shelter the grasslands from the air that moves down from the Arctic. When winter arrives, it does not arrive gradually. The season begins in October and lasts through April. During these months, the sun stays low, daylight shrinks. By December, the temperature often falls below minus 30 degrees Celsius. In some years, it reaches minus 40. In the worst years, it goes lower still. The wind is constant. It moves across the open land without interruption, carrying cold air that has travelled hundreds of kilometres from the frozen north. This wind does not gust and calm. It blows steadily, hour after hour, draining heat from anything exposed to it. Snow does fall, but not heavily. The steppe is semi-arid. Precipitation is sparse. What snow does accumulate is dry and fine. It does not insulate the ground. Instead, it scours across the surface, blown into drifts and hollows, leaving much of the earth bare and frozen solid. At night, the temperature drops further. The air is thin and dry. There is no cloud cover to hold warmth near the surface. Heat radiates upward into the clear sky. By the deep hours before dawn, the cold becomes absolute. Metal becomes brittle. Leather stiffens. Water, if it can be found, turns to ice within minutes. This is not a place where survival can be taken for granted. The cold is not symbolic. It is not poetic. It is a physical fact that demands response. Without shelter, without fire, without careful preparation, a person exposed to a winter night on the steppe would not survive until morning. For the nomadic people who live here, winter is the defining season. It shapes their calendar, their diet, their movements. Everything they build and everything they carry must answer the same question. How do we stay warm enough to live through the next 6 months? The landscape offers few resources. There are no forests to provide timber for heavy construction. There are no caves. The ground itself is frozen too hard to dig. What the steppe does offer is grass, and animals, and wind. From these, the people have built a dwelling that has remained essentially unchanged for 3,000 years. It is small, portable, and efficient. It can be assembled in a few hours and dismantled just as quickly. It weighs little enough to be carried by livestock, and it keeps its occupants alive through nights that would kill them in the open air. The dwelling is called a yurt. In other languages, it is sometimes called a yurt. But to the people who live in it, the word yurt means home. Not tent, not shelter. Home. This distinction matters. A yurt is not a temporary structure. It is not a compromise. It is the centre of domestic life, the place where families sleep and eat and gather, where children are born and elders die. It is designed not just to protect, but to allow rest, to allow sleep, to create a pocket of warmth and stillness in a landscape that offers neither. By the time winter fully settles over the steppe, every gear has been prepared. Extra layers of felt have been added to the walls. Fuel has been gathered and stacked nearby. The entrance has been positioned to face away from the prevailing wind. Inside, the space has been organised according to principles that are both practical and sacred, and then the family waits. They wait for the sun to set, for the temperature to fall, for the darkness to deepen. They wait for the long night to begin. When it does, they are ready. The gyr is a circle. From above, it appears as a round dome sitting low against the ground. It has no corners, no flat walls, no projections. The shape is deliberate. A circular structure presents no surface perpendicular to the wind. When the air strikes the curved felt walls, it flows around them rather than pressing against them. This reduces the force the wind can exert on the frame. It also reduces the surface area through which heat can escape. If the same volume were enclosed in a rectangular building, the walls would have more total surface. More surface means more contact with the cold air outside. More contact means more heat loss. The circular shape reduces this contact by as much as 10%. In a climate where every degree of warmth must be generated and guarded carefully, 10% is significant. The GR is also low. The walls stand only slightly taller than a person. The roof rises to a peak at the centre, but even there the height is modest. This keeps the interior volume small. A smaller volume requires less heat to warm. It also prevents the warmth from rising too far above the sleeping area. In a tall room, heat gathers near the ceiling, out of reach. In a gyr, the heat stays where it is needed. The structure itself is made of wood. Not logs or planks, but slender poles and lattice sections. These are light enough to be carried but strong enough to support the weight of the felt covering and the force of the wind. The framework consists of several parts. The base is formed by sections of collapsible lattice called khana. Each section is made of thin willow branches crossed in a diamond pattern and joined at the intersections. The sections can be folded flat for transport and then expanded and connected to form a circular wall. The number of sections varies. A small gyr might use 4, a larger one might use 6 or 8. The more sections, the larger the circle and the more space inside, but also the more felt required to cover it, and the more fuel needed to keep it warm. Once the lattice wall is in place, the roof is built. Long poles called uni radiate from the top of the wall to a wooden ring at the centre of the roof. This ring is called the tuno. It is the crown of the dwelling. The roof poles fit into sockets carved into the ring, creating a stable dome. The entire frame is held together not with nails or pegs, but with leather thongs. These are usually made from camel hide. Leather allows the frame to flex slightly when the wind shakes it. A rigid frame would crack. A flexible one absorbs the stress and holds. Over this wooden skeleton, layers of felt are stretched and tied. The felt is thick and heavy. It is made from the wool of sheep, processed in a way that compresses the fibres into a dense, insulating fabric. We will return to the felt later. For now, it is enough to know that it is the primary barrier between the interior warmth and the exterior cold. The felt is held in place by ropes. These ropes are made from braided horsehair or yak hair. They wrap around the gyr horizontally, binding the felt tight against the frame. In winter, additional ropes are added. The felt is compressed as much as possible to eliminate gaps where cold air might slip through. At the top of the gyr, the tuno remains open. This is not an oversight. The opening is necessary. It serves as a vent for the smoke from the fire inside, but it is also carefully managed. A square piece of felt called the urk can be pulled across the opening to reduce the size of the hole or close it partially when the fire is low. The door is small and positioned to face south. This orientation is not arbitrary. The prevailing winds in winter come from the north. By placing the door on the southern side, the entrance is sheltered. The southern exposure also allows the gyr to receive what little sunlight is available. During the short winter days, the door itself is a wooden frame covered with felt. It is not hinged, but set into the entrance and barred from the inside at night. During the day, it can be propped open. At night, it is closed and sealed as tightly as possible. From the outside, the gyr is simple. It is a pale dome sitting on the snow-dusted grass. There is no decoration, no paint, just the natural colour of the felt, which ranges from cream to light brown depending on the wool used. Inside, the space is unpartitioned. There are no rooms, no dividers. The entire interior is one circular area, but this does not mean it is disorganized. The space is divided by invisible lines, by tradition, by a sense of order that every person raised in a gyr understands instinctively. The floor is earth. In winter, it is frozen solid. Over this, felt mats are laid. These mats are thick and layered. They provide insulation from the ground, and a surface that is softer and warmer than bare earth. Around, the perimeter, against the walls, are the sleeping areas and storage. At the centre, slightly toward the back, is the stove. The stove is small, made of metal, with a chimney pipe that rises straight up to the tonneau. Everything in the gyr has a place. Everything is within reach. There is no wasted space, no clutter. The dwelling is efficient because it must be. It is a machine for living, designed by people who cannot afford inefficiency. The word gyr does not translate as tent or dwelling. It translates as home. This is not sentiment. It is precision. For the people who live on the steppe, the gyr is not a shelter they use while their real home is elsewhere. It is the home itself. It is where they were born, where they sleep, where they gather as a family. It is the one constant in a life of movement. And in winter, it is the only thing standing between them and the cold. The circle is the most efficient shape for holding heat. This is not intuition. It is geometry. A circle encloses the maximum area with the minimum perimeter. If you draw a square and a circle, both with the same interior space, the circle will have a shorter boundary. A shorter boundary means less surface through which heat can escape to the outside air. In the language of thermal engineering, this is described using the shape coefficient. The shape coefficient is the ratio of a building's exterior surface area to its interior volume. A lower coefficient means less heat loss. Calculations show that converting a rectangular floor plan into a circular one, while keeping the height the same, reduces the shape coefficient by approximately 0.05 to 0.1 inverse meters. This reduction translates directly into fuel savings. Less surface area means less heat conducted through the walls. Less heat conducted through the walls means less fuel burned to maintain the same interior temperature. For nomads on the steppe, fuel is not unlimited. Trees are scarce. What can be burned must be gathered, dried, and stored. Every bit of warmth that can be conserved is warmth that does not need to be generated. The circular shape of the gyr is not aesthetic. It is a solution to a problem of survival. The low profile of the gyr serves a similar function. A tall building loses heat through its roof and upper walls. The warm air inside rises. If the ceiling is high, the warmth accumulates far above the occupants, doing them no good. In the gyr, the ceiling is close. The warm air has nowhere to rise. It stays near the floor where the family sleeps. The domed roof also helps. A flat roof would collect snow and require heavy support beams. A domed roof sheds snow naturally. The weight slides off rather than accumulating. This keeps the structure light and reduces the need for thick timbers that would be difficult to transport. The dome also reflects heat. When the fire burns in the centre of the gyr, the heat radiates outward in all directions. Some of it strikes the felt walls and is absorbed or conducted outside. But some of it strikes the sloped ceiling and is reflected back down into the living space. The curve of the dome acts as a passive reflector, distributing warmth more evenly than a flat surface would. The positioning of the door matters as well. By facing south, the entrance receives the most sunlight during the short winter days. Even weak sunlight provides some passive heating. More importantly, the south-facing door is sheltered from the north wind, which is the coldest and most persistent. Opening the door to the north would allow cold air to pour directly inside every time someone entered or exited. By placing the door on the southern side, the entrance is in a relative calm zone. The wind wraps around the gyr from the north and flows past the southern side with less force. Inside, the organisation of space also contributes to thermal efficiency. The stove is placed near the centre, slightly toward the back. This central position allows heat to radiate evenly to all parts of the interior. If the stove were placed against a wall, one side of the gyr would be warm and the other cold. Centred, the heat spreads. The sleeping areas are arranged around the perimeter. This keeps the beds close to the walls, which are the coldest part of the interior. But the beds themselves are raised. They are not placed directly on the ground. They sit on low wooden platforms or frames, lifting the sleepers above the coldest layer of air, which sinks to the floor. This stratification of air is important. Cold air is denser than warm air. It settles. If you sleep on the ground, you sleep in the coldest zone. If you sleep even a few inches above the ground, you sleep in slightly warmer air. The difference is small but measurable. Over the course of a long winter night it matters. The felt mats on the floor also provide insulation. Felt is a poor conductor of heat. It traps air between its fibres. Air is an excellent insulator. By placing thick, felt mats over the frozen earth, the occupants create a barrier that slows the flow of heat from their bodies into the ground. The walls themselves are layered. In summer, a gyr might have only 1 or 2 layers of felt. In winter, families add more. 3 layers is common. 4 is not unusual. Each layer traps a thin film of air between itself and the next. These air gaps add to the overall insulation. The felt is also compressed. The ropes that bind it to the frame pull it tight, squeezing out large air pockets. This compression increases the density of the material, which improves its resistance to wind. Wind can penetrate loose fabric, carrying cold air through. Compressed felt resists this penetration. At the joints where the wall meets the roof, and where the roof meets the tonneau, there are potential gaps. These are sealed as carefully as possible. Felt strips are folded and tucked. Ropes are tightened. In some cases, families pack snow around the base of the gyr, creating a berm that blocks wind from slipping under the wall edge. Every detail of the gyr's shape and construction serves the same purpose, to create a stable thermal boundary between the warm interior and the cold exterior. The circle minimises surface area. The low dome minimises volume. The layered felt minimises conduction. The raised beds minimise contact with the frozen ground. None of these strategies alone would be sufficient. Together, they form a system. The gyr is not one innovation, but many, each addressing a different aspect of the thermal problem. And yet, the shape itself is only the container. It holds warmth, but it does not generate it. For that, the family depends on materials, on fuel, on fire, and on the wool that covers the frame. The sheep that graze the Mongolian steppe are not like the sheep raised in gentler climates. They are smaller, hardier, adapted to cold and scarcity. They are often called fat-tailed carpet wool sheep. The name describes 2 of their key features. The fat tail is a reserve of energy. In the summer, when grass is abundant, the sheep store fat in a large tail that can weigh several kilograms. In the winter, when forage is buried under snow, the sheep draw on this reserve. It is a biological strategy for surviving lean months. The wool is the other adaptation. It is thick and coarse, designed to protect the animal from wind and cold. The individual fibres are wider than the wool of breeds raised for fine textiles. They range from 22 to 35 micrometers in diameter. This makes the wool too rough for soft clothing, but ideal for felt. Felt is not woven. It is not spun. It is a compressed mass of fibres that have been mechanically interlocked. The process relies on the structure of the wool fibre itself. Under magnification, a wool fibre is covered in tiny scales. These scales overlap like the tiles on a roof. When wool is moistened and agitated, the scales catch on each other. The fibres tangle and lock together. The more the wool is worked, the tighter the tangle becomes. Eventually, the mass of fibres forms a cohesive sheet that will not come apart. This is felt. The quality of the felt depends on the quality of the wool. Mongolian sheep produce wool that is well suited to felting. The fibres are strong. They have the right degree of crimp, the natural waviness that helps them interlock, and they are available in abundance. Shearing happens once a year in the spring. The sheep have grown their winter coat through the cold months. By spring, the wool is long and thick. The herders shear the animals by hand using knives or scissors. The fleece comes off in large pieces. After shearing, the wool is cleaned. It is soaked in water to remove dirt, grease and debris. Then it is dried in the sun. Once dry, it is carded. Carding is the process of combing the wool to align the fibres and remove any remaining tangles or foreign matter. This is done by hand, using wooden paddles studded with metal teeth. The carded wool is then ready to be made into felt. The process is labour-intensive. The wool is spread out in a thin, even layer on a large mat, usually made of canvas or leather. Water is sprinkled over it. Sometimes soap is added. Then the mat is rolled up tightly, with the wool inside. The rolled mat is tied with a rope and then dragged or rolled back and forth. Sometimes it is done by hand, sometimes it is tied to a horse and pulled across the ground. The constant pressure and friction cause the fibres to compress and interlock. After several hours, the mat is unrolled. What was loose wool is now a solid sheet of felt. The felt is thick. A single layer can be several millimetres deep. It is also heavy when wet. It must be dried thoroughly before it can be used. Once dry, it is surprisingly light for its density. The colour of the felt depends on the wool. Most Mongolian sheep produce white or cream-coloured wool, so the felt is usually pale. Some families dye the felt, but this is uncommon. Undyed felt is preferred for gers because it reflects sunlight in the summer, helping to keep the interior cool. The felt is cut to size. For the walls, large rectangular panels are needed. For the roof, wedge-shaped pieces that fit together like the segments of an orange. The tonneau, the crown ring, is also covered with a separate piece of felt. Each gyr requires a substantial amount of felt. A typical family gyr might use 30 to 50 kilograms of wool. This represents the fleece of many sheep. A family with a large herd can produce their own felt. A family with a smaller herd may trade for it or purchase it from others. The felt is not permanent. It wears out. It is exposed to sun, wind, rain, and smoke. Over time, it becomes thin and brittle. A well-maintained piece of felt might last 5 to 10 years. Then it must be replaced. This means that felting is not a one-time task, but an ongoing part of nomadic life. Every year wool is gathered. Every few years, new felt is made. The knowledge of how to make it is passed down without interruption. Children learn by watching and helping. By the time they are adults, they know the process by heart. The felt that covers a gyr in winter is the product of this knowledge. It is not purchased from a distant supplier. It is made by the family or by someone they know. It is a direct transformation of the resources of the steppe, grass, sheep, labour, into the material that will keep them alive. The wool itself is remarkable not just for its availability but for its physical properties. When processed into felt, it becomes one of the most effective natural insulators known. Thermal conductivity is the measure of how easily heat passes through a material. The lower the conductivity, the better the insulation. Mongolian sheep wool felt has a thermal conductivity of 0.037 to 0.041 watts per metre, Kelvin. This places it on par with modern synthetic insulators like glass wool or expanded polystyrene. But felt has advantages that synthetics do not. It is breathable. It allows moisture vapour to pass through while still blocking air movement. This prevents condensation inside the gyr. When warm, moist air from cooking or breathing meets a cold surface, it condenses into water. In a dwelling where the walls are below freezing, condensation would freeze into ice. Felt absorbs the moisture instead, holding it within its fibres until it can evaporate. Felt is also fire-resistant. Wool does not ignite easily. It requires sustained exposure to flame and high temperatures, around 560 degrees Celsius, before it will burn. Even when it does ignite, it does not melt or drip like synthetic materials. It chars and self-extinguishes. In a dwelling centred around an open fire, this is a critical safety feature. The wool fibres themselves are resilient. They can be compressed and will spring back to shape. They can be bent and twisted without breaking. This durability is important. For a material that must be packed, transported, stretched and lashed to a frame repeatedly. And yet, for all its technical performance, the felt is simply wool. It is an animal fibre, harvested from living sheep, processed by hand, and shaped into a fabric using techniques that predate written history. It is this felt, this wool from the flock, that forms the primary defence against the winter cold. Without it, the geometry of the gyr would be meaningless. The circular shape would still be efficient, but there would be nothing to hold the warmth inside. The felt is the boundary. It is the skin of the dwelling. And in winter, when the temperature outside drops to 40 below zero. The quality of that skin determines whether the family inside will sleep in comfort or struggle to survive the night. The making of felt begins long before the wool is spread on the mat. It begins with the flock. The sheep must be healthy. They must be well fed through the summer so that they grow a full coat by autumn. A weak sheep produces thin wool. Thin wool makes poor felt. The herders know this. They know which pastures to seek, which animals to cull, which to breed. The quality of the felt depends on the quality of the flock. Shearing is timed carefully. Too early, and the wool has not reached its full length. Too late, and the sheep begin to shed naturally, losing fibre before it can be collected. Spring is the preferred time. The worst of the winter cold has passed. The sheep no longer need their full coats, and the herders need time to process the wool before the next winter arrives. The fleece, once removed, is full of dirt. Sheep lie on the ground. They move through dust. Their wool collects debris, bits of grass, seeds, dried manure. All of this must be removed. The first cleaning is done dry. The fleece is shaken and picked over by hand. Large clumps of dirt are pulled out. Matted sections are separated. This takes time. A single fleece can take an hour to clean, properly. Then the wool is washed. It is submerged in water, usually in a stream or river if one is nearby. If water is scarce, the washing is done in basins. The wool is agitated by hand, squeezed and kneaded until the water runs clear. The natural grease in the wool, called lanolin, helps it shed water, but enough remains in the fibre to provide some protection during the felting process. After washing, the wool is dried. It is spread out in the sun, turned occasionally to ensure even drying. Damp wool is heavy and prone to mildew. Dry wool is light and ready to work. Carding comes next. This is the process of aligning the fibres. Carding paddles are simple tools. Wooden boards with handles, their faces studded with rows of bent wire teeth. A clump of wool is placed on one paddle. The second paddle is drawn across it, pulling the fibres through the teeth. This separates the individual strands and arranges them in parallel. Carding is repetitive work. It is often done by children or by women while sitting together in the afternoon. The rhythm of the paddles, the soft scrape of wire on wool, becomes a background sound of nomadic life. Bags of carded wool accumulate slowly over weeks. When enough wool has been prepared, the felting can begin. This is a communal task. One person cannot make felt efficiently. It requires several people working together. A large mat is laid out on the ground. This mat is usually made of canvas or thick leather. It must be strong enough to withstand the forces of rolling and dragging. The carded wool is spread across the mat in a thin, even layer. The thickness must be consistent. Thin spots will become weak points in the finished felt. Thick spots will not compress properly. The layer of wool is then moistened. Water is sprinkled over it, sometimes mixed with soap. The soap helps the fibres slip past each other during the initial stages of compression. Too much water, and the wool becomes soggy and difficult to work. Too little, and the fibres will not interlock. The right amount is learned through experience. Once the wool is damp, the mat is rolled up tightly. The roll is tied with ropes to keep it from unravelling. Then the work of compression begins. The rolled mat is pushed back and forth across the ground. Sometimes it is done by hand, with people kneeling and using their body weight to press it down as they roll it. Sometimes it's tied to a horse or camel and dragged. The friction and pressure cause the wet wool inside to shift and compress. This process continues for hours. The mat is unrolled periodically to check the progress. If the felt is forming unevenly, the wool is redistributed. More water is added if needed. Then the mat is rolled again, and the work continues. Gradually the loose fibres begin to adhere to each other. The felt starts to hold its shape. When the mat is unrolled, the wool no longer looks like separate strands. It looks like a cohesive fabric, but it is not finished. The felt is still too soft. It must be worked further. The mat is rolled in a different direction. The felt is folded and pounded. This additional compression tightens the bond between the fibres. It also thins the felt slightly, making it denser and more uniform. By the end of the process, the felt has shrunk. What began as a layer of loose wool 2 meters wide and 3 meters long might now be a solid sheet 1.5 meters by 2 meters. The fibres have condensed into a fabric that is firm, flexible and resilient. The felt is then washed again. This removes the soap and any remaining loose fibres. It is wrung out as much as possible and then hung to dry. Drying takes time. Felt holds water. It can take several days for a thick piece to dry completely. Once dry, the felt is ready to use. It is cut to the dimensions needed for the gur. For the walls, large rectangular panels. For the roof, trapezoidal segments that narrow toward the top. For the door, a smaller, reinforced piece that will withstand constant handling. The edges are sometimes bound with leather or cloth to prevent fraying. The felt is folded and stored until it is time to cover the gur. In winter, when additional insulation is needed, the stored felt is brought out and layered over the existing covering. The process of making felt has not changed in thousands of years. The tools are the same. The technique is the same. The wool is the same. What has changed is the volume. In earlier centuries, when gurs were the only form of housing, every family made their own felt. Now, some families purchase felt from workshops in towns, but the knowledge remains widespread. Most nomadic families still know how to make it, even if they do not do so every year. The felt that results from this process is not perfect. It is not uniform. One section might be slightly thicker than another. The colour might vary depending on the wool used. There might be small flaws, thin spots, lumps, uneven edges, but it works. It insulates. It blocks wind. It absorbs moisture. It resists fire. And it does all of this using nothing but wool, water, and labour. In winter, when the temperature falls and the wind begins to howl across the steppe, the felt is the barrier that stands between the family and the cold. It is not a technological marvel. It is not an engineered composite. It is compressed sheep's wool. And it is enough. Summer on the steppe is brief. By September, the nights grow noticeably cooler. By October, frost appears on the grass in the mornings. The herders know what is coming. They begin to prepare. The gur that served well enough through the warmer months must now be fortified. The single or double layer of felt that provided shade and moderate insulation is no longer sufficient. Winter requires more. Families bring out the felt they have stored or made during the year. They inspect it carefully. Felt that has developed holes or worn thin is set aside for other uses. Only the best pieces, thick, intact, tightly compressed, are chosen for the winter covering. The first step is to remove the summer felt. The ropes are untied. The felt panels are lifted away from the frame. This exposes the wooden lattice and roof poles. The frame itself is inspected. Joints are checked. Leather thongs that have stretched or frayed are replaced. Any damage to the wood is repaired. Then the layering begins. The first layer of felt goes on. It is positioned carefully to cover the lattice walls completely, with some overlap at the edges. The felt is heavy. It takes 2 or more people to lift and position each panel. Once in place, it is tied loosely to the frame. The second layer follows. This one is offset slightly from the first, so that the seams do not align. If the seams were stacked directly on top of each other, cold air could penetrate through the gap. By staggering the layers, any potential breach in one layer is covered by solid felt in the next. The second layer is also tied in place. Then comes the third. In the coldest regions or in particularly harsh winters, a fourth layer might be added. Each additional layer increases the total thickness of the insulation. It also increases the weight. The frame must be strong enough to support it. Once all the wall layers are in position, the roof is covered. The same process applies. Multiple layers of felt, staggered and overlapped, are stretched over the radiating roof poles. The felt is cut in trapezoidal shapes that narrow as they approach the tuno at the top. These pieces fit together like the petals of a flower converging at the crown. At the tuno itself, a separate piece of felt is used. This is the square flap that can be pulled over the opening to close it partially or fully. The yurk is attached with a rope that hangs down into the interior of the gur. By pulling this rope, the occupants can adjust the size of the opening without going outside. With the felt in place, the ropes are tightened. These are the hoshlin, the binding ropes that wrap horizontally around the exterior of the gur. They are made from braided horsehair or yak hair. These materials are chosen for their strength and durability. They do not rot easily. They do not stretch excessively when wet. The ropes are passed around the gyr in bands spaced evenly from bottom to top. Each rope is pulled tight and tied. The tension compresses the felt against the frame, eliminating air gaps and creating a smooth, firm surface. In winter, additional ropes are added. The more compression, the better the insulation. Where the felt meets the ground, special attention is paid. This is the point where cold air is most likely to infiltrate. The bottom edge of the felt is weighted down. Sometimes stones are placed along the perimeter, sometimes bags of sand. In some cases, families stack firewood around the base of the gyr. The wood serves a dual purpose. It blocks the wind and provides fuel close at hand. In the regions where snow is reliable, the snow itself becomes an insulator. After the first snowfall, families shovel snow against the base of the gyr, creating a low berm that encircles the dwelling. Snow is full of air pockets. Air is a poor conductor of heat. A layer of packed snow adds another barrier against the cold. The door is also reinforced. The standard door is a wooden frame covered with felt. In winter, an additional felt curtain is hung inside the door. This creates a small air gap, a primitive airlock. When someone enters, they pass through the outer door and then through the inner curtain. This reduces the amount of cold air that rushes directly into the main living space. Inside, the floor is layered as well. The bare earth, frozen hard, is first covered with a base layer of thin felt or woven mats. Over this, thicker felt rugs are placed. These are called skyrdeg. They are dense and heavy, sometimes several centimetres thick. They provide insulation from the ground and a surface that is warmer to walk on than the frozen earth. The preparation is methodical. It follows a sequence that has been refined over generations. Nothing is left to chance. Every seam is checked. Every rope is tested. Every layer is positioned with care. This work is done in daylight, while the weather is still tolerable. Families know that once deep winter sets in, making adjustments to the exterior of the gyr becomes difficult. Fingers grow numb in minutes. Felt becomes stiff and hard to handle. Ropes freeze and resist tying. Better to complete the work in October or November than to struggle with it in January. The result is a structure that looks, from the outside, almost unchanged. It is still a pale dome on the steppe, but it is now a dome wrapped in multiple layers of insulation, bound tightly, sealed at the base, and prepared to withstand months of relentless cold. The difference is not visible. It is felt. Inside, with the layers in place, the temperature will be measurably warmer than it would be with a single layer. The wind, which might have caused the felt to flutter and allowed cold air to seep through, now presses against a firm, compressed surface and flows around it. The family has created a thermal shell. It is not impermeable. Heat will still escape. Cold will still press in. But the rate of exchange has been slowed. The system has been optimized. And now they wait. They wait for the first true cold. They wait for the night when the temperature drops below -20, then -30. They wait to see if their preparation is sufficient. It always is, because the preparation is not guesswork. It is knowledge, tested every year, adjusted as needed, and passed down without interruption. The gyr, layered and bound, stands ready. The felt is what the eye sees, but the felt is only a covering. Beneath it lies the frame that gives the gyr its shape and bears its weight. This frame is made of wood, not heavy timber but slender poles and lattice sections carefully chosen and precisely cut. The wood must be strong enough to support the structure, but light enough to be carried when the family moves. It must be flexible enough to withstand wind without breaking, but rigid enough to hold its form under the weight of multiple layers of felt. The primary wood used is willow. Willow grows along the rivers and streams that cut through the steppe. It is not abundant, but it is available. Willow branches are straight and resilient. They bend without snapping. They're easy to work with simple tools. The frame consists of 4 main components. The kana are the lattice wall sections. The uni are the roof poles. The tuno is the crown ring. The bagana are the support pillars. The kana are constructed first. Each section, is a collapsible lattice made of thin willow sticks crossed in a diamond pattern. The sticks are joined at their intersections, but not rigidly. They are fastened with leather thongs, or, in some modern yurts, with small metal rivets. This allows the lattice to fold flat for transport and then expand into a wide, stable wall when set up. A single khana section, when fully extended, forms a segment of the circular wall. The sections are connected to each other end to end, creating a continuous lattice that curves into a circle. The number of sections determines the diameter of the yurt. 4 sections make a small dwelling suitable for a single family. 6 or 8 sections make a larger one with more interior space, but also more felt required and more fuel needed to keep it warm. The lattice is not solid. It is open, with diamond-shaped gaps between the crossed sticks. This openness reduces weight and allows some air circulation, but it also means the lattice alone provides no insulation. It is a skeleton, not a barrier. The felt is what keeps the cold out. Once the khana are in place, forming the circular wall, the roof is built. The uni are the roof poles. These are longer than the lattice sticks, usually 2 to 3 meters in length. One end of each uni rests on the top edge of the lattice wall. The other end fits into a socket in the tuno, the crown ring. The tuno is a wooden hoop, typically about 1 meter in diameter. It is reinforced with cross pieces to keep it from warping. The edge of the tuno is carved with evenly spaced sockets, each designed to hold the end of a roof pole. The number of sockets matches the number of poles, which can range from 60 to over 100 depending on the size of the yurt. The roof poles radiate from the tuno like the spokes of a wheel. They slope downward at a gentle angle, creating the dome shape. The poles are not attached to the lattice wall. They simply rest on it, held in place by their own weight and the tension of the felt covering. This loose connection allows the frame to flex slightly when the wind blows, absorbing stress rather than resisting it rigidly. In larger yurts, the tuno is heavy. It cannot be supported by the roof poles alone. 2 vertical pillars, the bagana, are placed inside their yurt to hold the tuno up. These pillars are carved from thicker wood and stand about chest height. They are positioned symmetrically, usually on either side of the central stove. The tuno rests on top of the bagana, and the roof poles radiate outward from there. The bagana are more than structural. They are symbolic. They represent the connection between earth and sky. In traditional belief, they are sacred elements of the yurt, and certain rituals involve them. But their practical function is clear. They carry the weight of the roof and prevent it from sagging. The entire frame is held together with leather. Not nails, not screws. Leather thongs made from camel hide. Camel leather is strong and flexible. When wet, it can be stretched and tightened. When it dries, it shrinks slightly, pulling the joints tighter. This creates a secure connection that can still move. The flexibility is important. The steppe wind does not blow steadily. It gusts. It shifts direction. A rigid frame would resist these forces and eventually crack or break. A flexible frame absorbs them. The lattice sways slightly. The roof poles shift. The tuno rocks. But nothing breaks. Over time, the leather thongs stretch and weaken. They are inspected regularly and replaced as needed. This is routine maintenance. A family expects to replace several thongs each year. It is part of the rhythm of maintaining the yurt. The frame, when assembled, is surprisingly light. 2 people can carry a disassembled yurt, the lattice sections, the roof poles, the tuno, the pillars, on the back of a single camel or yak. This portability is essential. Nomadic families move several times a year following the grass. If the dwelling were too heavy to move, they could not be nomadic. But lightness does not mean fragility. The frame is strong. It can support the weight of thick felt layers, even when those layers are heavy with rain or snow. It can withstand winds that would flatten a poorly designed structure, and it can do so year after year with only minor repairs. The design of the frame has not changed significantly in centuries. Archaeological evidence shows that the basic principles, collapsible lattice walls, radiating roof poles, a central crown ring, were in use during the Xiongnu Empire, more than 2,000 years ago. The materials have remained the same, the techniques have remained the same. This continuity is not due to lack of innovation. It is due to the fact that the design works. It solves the problems it was meant to solve. It is portable, durable, adaptable, and efficient. There is no need to change it. In winter, the frame plays a specific role. It holds the felt in place. It provides the structure onto which the insulation is layered. Without the frame, the felt would collapse. Without the felt, the frame would provide no warmth. The two work together, the frame is the skeleton. The felt is the skin. And between them, they create a dwelling that can stand against the winter. The family trusts the frame. They trust it because they know how it is made. They know which wood was used, which joints were tied, which thongs were replaced. There is no hidden weakness. There is no unknown flaw. When the wind howls and the felt shudders, the frame holds. It flexes, but it holds. And inside, the family sleeps, knowing that the structure above them has been tested 1,000 times before and has never failed. Fire is not optional. In a climate where the temperature can drop to -40 degrees, fire is survival. Without it, no amount of felt or careful construction will keep a person alive through the night. But the steppe does not offer wood. There are no forests. Trees grow only along rivers, and even there they are sparse. The willow used for the gyre frame is precious. It is not burned. It is saved, used, repaired, and passed down. To burn it would be to destroy the dwelling itself. The primary fuel is argil. Argil is dried animal dung. It is collected from the sheep, goats, cattle, horses, and camels that make up the nomadic herds. It is abundant, it is renewable, and when properly dried, it burns. The collection of argil is a constant task. It begins in the spring and continues through the summer and autumn. Children often do this work. They walk through the areas where the herds have grazed, picking up the dried dung and placing it in bags or baskets. The work is not considered demeaning. It is practical. It is necessary. Fresh dung is wet and will not burn. It must be dried thoroughly. On the steppe, where the air is dry and the sun is strong, this happens naturally. Dung left on the ground dries within days. The outer surface hardens. The interior moisture evaporates. What remains is a lightweight, fibrous material that is easy to handle and store. Dried argil is stacked near the gyre. In summer, a modest pile is sufficient. In winter, the pile must be large. A family might go through 10 to 15 kilograms of argil per day during the coldest months. This means that hundreds of kilograms must be gathered and stored before winter begins. The quality of argil varies depending on the animal. Sheep and goat dung is small and burns quickly. It produces a hot flame but does not last long. Cattle dung is larger and burns more slowly. It provides steady heat over a longer period. Horse dung is somewhere in between. Camel dung, when available, is prized. It is dense and burns with a slow, even heat that is ideal for maintaining warmth through the night. Argil does not burn like wood. It does not produce large flames. It smoulders. It glows. The heat is radiant and steady. There is smoke, but it is not as thick or acrid as wood smoke. It has a distinct earthy smell. To those raised in yurts, the smell is familiar. It is the smell of warmth, of home. The stove used to burn argil is simple. It is a metal box often made from repurposed steel or iron. It has a flat top for cooking and an opening at the front where fuel is added. A chimney pipe rises from the back of the stove and extends upward to the tonneau, venting the smoke outside. The stove is positioned at the centre of the gyre, slightly toward the back. This central placement allows heat to radiate evenly in all directions. The stove is not large. It is perhaps 1/2 metre wide and 1 metre tall. It does not need to be large. Its purpose is not to produce intense heat, but to produce sustained heat. Starting the fire requires preparation. First, a small amount of kindling is needed. This might be dry grass, shredded bark, or small twigs. The kindling is placed inside the stove. On top of it, a few pieces of argil are stacked. A flame is introduced, usually from a coal or ember kept smouldering from the previous fire. If no ember is available, the fire is started with flint and steel, or in modern times with matches. The kindling catches first. The flames spread to the argil. At first, the argil smokes heavily, but as it heats, it begins to glow. The smoke lessens, the heat increases. More argil is added piece by piece until the stove is full. Once the fire is established, it requires attention. Argol burns down to ash relatively quickly. To maintain the heat, fresh fuel must be added regularly. During the day, this is easy. Someone is always awake, always nearby. But at night, the fire must be managed differently. Before sleep, the family builds the fire as high as possible. The stove is packed with argol. The goal is to create a large mass of glowing fuel that will radiate heat for several hours without needing to be replenished. This is not always successful. The fire dies down. The interior cools. Someone must wake to add more fuel. This task often falls to the adults. One person might take the first shift, waking after a few hours to tend the fire. Another might take the second shift, waking before dawn, or the task might rotate, each family member taking responsibility on different nights. Waking to tend the fire is not seen as an interruption. It is part of the rhythm of winter nights. The person rises quietly, careful not to disturb the others. They add argol to the stove, wait until it catches, and then return to bed. The whole process takes only a few minutes. The heat from the stove does not fill the gyre evenly. The area closest to the stove is warmest. The area near the door is coolest. The sleeping arrangements reflect this. The elders and the youngest children sleep in the warmest spots. The adults, who are more resilient to cold, sleep in the cooler areas. The stove also serves other purposes. It is used for cooking. A pot of water or milk tea might simmer on the flat top during the day. Meat might be boiled. Bread might be toasted on the hot surface. The stove is the centre of domestic life, not just a source of heat, but a tool for preparing food and warming drink. In some regions, families have access to coal. Coal burns hotter and longer than argol. It requires less tending, but it is not always available, and it produces thick, acrid smoke. In urban gyre districts where coal is common, the air quality suffers. In rural areas, argol remains the fuel of choice. There are also bones. Animal bones, particularly the large bones of cattle or horses, can be burned. They smoulder slowly and produce heat over a long period, but they are not abundant, and they are often saved for the coldest nights or as a backup fuel when argol is running low. The management of fuel is a skill. Knowing how much to burn, when to add more, how to balance heat output with fuel conservation, all of this is learned through experience. A family that burns too much argol too quickly will run out before spring. A family that burns too little will suffer through cold nights. The relationship between fire and sleep is direct. The fire creates warmth. Warmth allows sleep. Without the fire, sleep would be shallow and interrupted by shivering. The body would struggle to maintain its core temperature. Rest would be incomplete. The fire also creates light. In the deep winter, when the sun sets early, the interior of the gyre would be completely dark without it. The glow of the stove provides enough light to move around, to see the faces of family members, to find what is needed. And the fire creates sound, the crackle of burning argol, the occasional pop of a pocket of moisture expanding, the soft hiss of air moving through the stove. These sounds are part of the sensory landscape of the gyre at night. They are reassuring. They signal that the fire is alive, that warmth is being produced, that the family is safe, fuel from the land, not wood, not coal, not oil, just the dried waste of the animals that graze the grass. It is humble, it is abundant, and it is enough. The interior of the gyre is a circle. It is also a map. Every part of the space has meaning. The location of objects, the placement of furniture, the position where each person sleeps. All of this is determined by tradition. The organisation is not arbitrary. It reflects social order, spiritual belief, and practical necessity. The entrance to the gyre always faces south. This is the fixed reference point. From the door, the rest of the space is defined. Directly opposite the door at the back of the gyre is the koimor. This is the north side. It is the most honoured part of the dwelling. The family altar is placed here. Photographs of ancestors might hang on the lattice wall. Religious items, if the family practices Buddhism, are kept here. This is where guests of high status are seated. It is also the warmest part of the gyre. The koimor is farthest from the door. When the door is opened, cold air rushes in, but it does not reach the back of the air immediately. The distance provides a buffer. The koimor is also positioned opposite the prevailing wind. Even when the wind presses against the northern Wall, the interior arrangement ensures that the most important area remains protected. The elders of the family sleep in the soimor. This is both respect and practicality. The elderly are more vulnerable to cold. They need the warmest spot. By placing them here, the family ensures their comfort and honours their position. The space to the west of the entrance is called the barun. This is the male side. It is where men sleep. It is also where male-associated items are stored. Saddles, bridles, tools, weapons. In a traditional nomadic household, the division is clear. Men do not sleep on the eastern side. Women do not sleep on the western side. The space to the east is called the zun. This is the female side. Women and children sleep here. The kitchen area, such as it is located here. Pots, utensils, food supplies, all are kept on the eastern side. The stove is at the centre, but the preparation of food happens on the zun side. This division is not rigid in a practical sense. During the day, people move freely throughout the ger. Men might cross to the eastern side to retrieve something. Women might move to the western side. But at night, the sleeping positions are fixed. Each person knows where they belong. The organisation of space also has a thermal logic. By grouping family members together on either side of the stove, the heat is shared more efficiently. Bodies close together create a shared warmth. The air between them is warmer than the air at the edges of the ger. This is social thermoregulation, using the collective body heat of the group to maintain a stable temperature. The sleeping areas are not on the ground. The frozen earth conducts heat away from the body. Sleeping directly on it would lead to rapid heat loss. Instead, families sleep on low platforms or raised beds. These are simple wooden frames, sometimes just planks laid across supports. The height is minimal, perhaps 10 to 20 centimetres, but it is enough to lift the sleeper above the coldest layer of air. On top of the platform, thick felt mats are placed. These are the sherdeg. They are layered, sometimes 2 or 3 deep. The felt provides insulation from below, preventing body heat from escaping into the wood and the frozen ground beneath. Over the felt, animal skins are spread. Sheepskin is common. The wool side faces up, providing a soft, warm surface to lie on. In wealthier families, marmot fur or even wolf pelts might be used. These furs are dense and insulating. They trap air close to the body, adding another layer of warmth. Blankets are piled on top. These are usually made of wool, sometimes quilted with cotton. In the coldest nights, several blankets might be used. The weight of the blankets helps. Heavy coverings reduce the movement of air around the body, which reduces convective heat loss. Pillows are small and firm, often stuffed with wool or feathers. The head is kept slightly elevated. This is not just for comfort, it helps with breathing. In the cold, dry air of the steppe, breathing through the nose warms the air before it enters the lungs. Keeping the head up facilitates this. Infants sleep next to their mothers. They are swaddled tightly in layers of cotton and sheepskin. The swaddling restricts movement, but it also conserves heat. A baby's surface area to volume ratio is high, which means they lose heat more quickly than adults. Swaddling reduces this loss. The proximity to the mother provides additional warmth and allows for easy feeding during the night. Children sleep in clusters. Brothers and sisters lie close together, sharing blankets. The younger ones are positioned toward the centre, where it is warmest. The older ones, who are more resilient, sleep toward the edges. The arrangement of bodies is intentional. It is not random. The family knows, without discussion, who sleeps where. The pattern has been established since childhood. It reflects hierarchy, vulnerability, and need. The space near the door is the coldest. This is where items that do not need warmth are stored. Boots, outer garments, tools. No one sleeps near the door unless the gyr is crowded and there is no other option. The floor itself is covered entirely. There is no bare ground visible. Felt mats overlap, creating a continuous insulated surface. Walking on the mats is quieter than walking on frozen earth. The mats also absorb moisture from boots and clothing, keeping the interior drier. The spatial organisation extends to objects as well. Everything has a place. Water containers are kept on the eastern side near the kitchen area. Firewood and argol are stacked near the stove within easy reach. Ropes and repair materials hang from the lattice walls. Nothing is left in the middle of the floor. The central space must remain open for movement. This order is maintained rigorously. In a small space, disorder creates inefficiency. Time is wasted searching for things. Heat is lost when the door must be opened to retrieve something stored outside. By keeping everything in its designated place, the family minimizes disruption and maximizes efficiency. The geography of the gyr is also a cosmology. The floor represents the earth. The dome represents the sky. The tuno, the crown ring, is the portal between them. The smoke rising from the stove passes through the tuno, carrying prayers and offerings to the heavens. This symbolic structure is not separate from the practical structure. It is integrated. The same design that maximizes warmth also reflects a worldview. The gyr is not just a shelter. It is a model of the universe, with the family at the center, surrounded by the elements, protected by tradition. At night, when the family settles into their sleeping positions, they are not just lying down to rest. They are taking their place in an order that has been maintained for generations, each person in their assigned location, each object in its proper place, the fire glowing at the center, the felt walls enclosing the circle, the stars visible through the tuno above. It is a small world, but it is complete. The cold does not come from the air alone. It comes from the ground. The earth beneath the gyr is frozen. In winter, the frost line extends deep, sometimes more than a metre below the surface. The temperature of the ground is far below freezing. This frozen mass acts as a heat sink, drawing warmth away from anything in contact with it. A person lying directly on a frozen ground would lose body heat rapidly. Conduction, the transfer of heat through direct contact, is efficient. The ground is cold, the body is warm. Heat flows from warm to cold. Within minutes, the body's core temperature would begin to drop. Within an hour, hypothermia would set in. The solution is simple. Do not sleep on the ground. Nomadic families sleep on raised platforms. These are not elaborate pieces of furniture. They are functional structures built to solve a specific problem. The frame is made of wood, usually the same willow used for the gyr itself, or sometimes salvaged planks if available. The design is minimal. 4 corner posts, roughly knee-high, support a rectangular frame. Across this frame, planks or woven slats are laid to create a sleeping surface. The height of the platform is critical. It does not need to be high. Even a few centimetres of elevation makes a difference. Cold air is denser than warm air. It sinks. The coldest air in the gyr settles at floor level. By sleeping above this layer, even slightly, the occupants sleep in warmer air. The platform also creates a buffer of still air between the sleeper and the ground. Air is a poor conductor of heat. This trapped air acts as insulation, slowing the transfer of heat from the body to the frozen earth below. But the wooden platform alone is not enough. Wood conducts heat more readily than air. Lying directly on wood is better than lying on frozen ground, but it is still not comfortable. The wood would feel cold to the touch. Over the course of a long night, it would draw heat away from the sleeper. So the platform is covered. The first layer is felt. Thick panels of felt are laid across the wooden slats. This felt is the same material used to insulate the walls, though often slightly thinner or of lower quality. It does not need to withstand wind or weather. It only needs to provide thermal resistance. The felt layer is not a single piece. It is often made up of several smaller pieces, overlapped to eliminate gaps. The felt is heavy enough to stay in place without being tied down. It drapes over the edges of the platform, creating a continuous surface. On top of the felt, animal skins are placed. Sheepskin is the most common. The skin is tanned and dried with the wool left intact. The wool side faces upward, providing a soft, insulating layer that is pleasant to lie on. Sheepskin has natural loft. The wool fibres trap air, creating tiny pockets of insulation that conform to the shape of the body. In some families, other furs are used. Marmot pelts are prized for their density and warmth. Marmots are hunted in the summer, and their pelts are dried and stored. A single marmot pelt is small, so several are sewn together to create a larger covering. The fur is thick and soft, providing excellent insulation. Goat hides are also used, though they are less warm than sheepskin. Cattle hides are too stiff and heavy for bedding, but they might be used as rugs on the floor near the bed, providing a warmer surface for bare feet when rising in the morning. Over the animal skins, blankets are piled. These are woven from wool, usually in natural colours, cream, brown, grey. The weave is tight enough to block air movement but loose enough to retain loft. Loft is important. A compressed blanket loses its insulating properties. A blanket with loft traps air and holds warmth. The number of blankets varies. In early winter, 1 or 2 might be sufficient. In deep winter, 3 or 4 or more might be used. The blankets are layered, with the heaviest on top. Weight helps. It presses the blankets down around the body, reducing drafts and air movement. Some families use quilts. These are blankets with an inner layer of cotton or wool batting stitched through at intervals to keep the filling from shifting. Quilts are warmer than simple woven blankets because the batting creates additional loft. The bedding is not washed frequently. Water is scarce in winter. Heating water for washing is fuel intensive. The bedding is aired when possible, taken outside on sunny days and shaken to remove dust and odours. But full washing is reserved for spring, when water is more available and the weather allows for thorough drying. Despite the infrequent washing, the bedding does not become foul. The dry, cold air of the steppe is not conducive to the growth of bacteria or mould. Sweat evaporates quickly. The wool and felt absorb moisture without feeling damp. The overall effect is surprisingly hygienic given the circumstances. Pillows are small. They are not plush or overfilled. A typical pillow is a simple cloth sack stuffed with wool or feathers, firm enough to provide support but not so soft that the head sinks into it. The pillow keeps the head slightly elevated, which helps with breathing and reduces the sensation of cold air entering the nose and mouth. The arrangement of the bed is the same every night. The felt goes down first, then the skins, then the blankets, the pillow at the head. The process is routine. It is done without thought, the way a hand reaches for a familiar tool. The bed is positioned against the wall of the germ, in the koimor or along the eastern or western sides, depending on the person's role in the family. The back of the bed is close to the lattice wall. The felt covering the wall provides some insulation, but the wall is still the coldest part of the ger. The bed is positioned so that the sleeper's back is toward the wall and their front is toward the centre, where the stove radiates heat. This orientation is not accidental. Heat radiates outward from the stove. By facing the stove, the sleeper's front receives warmth. The back against the wall is protected by the layers of blankets and the insulation of the wall itself. The bed is also a place of rest during the day. In winter, when outdoor work is limited, family members might sit on the bed, wrapped in blankets, drinking tea and talking. The bed is not just for sleeping. It is a refuge from the cold, a place to retreat when the interior temperature is not quite comfortable. Children sometimes play on the beds, burrowing under the blankets and creating small forts. This play is tolerated. It keeps them occupied. It also keeps them warm. The beds are the warmest spots in the ger, aside from the area immediately around the stove. At night, the family does not all go to bed at the same time. The routine is staggered. The youngest children are put to bed first. They are settled under the blankets, swaddled or dressed in warm layers, then the older children, then the adults. The last person to bed is usually the one responsible for the first fire-tending shift. Before lying down, each person checks their bedding. Are the blankets positioned correctly? Is the pillow in place? Are there any drafts? Small adjustments are made. A blanket is pulled tighter. A gap is closed. The body settles into the familiar depression in the felt and skins. The sensation of lying down is immediate warmth. The layers trap body heat quickly. The wool and fur press against the skin, creating contact warmth. The blankets overhead block the cooler air above. Within minutes, the microclimate under the blankets is noticeably warmer than the air in the rest of the ger. Sleep comes more easily in this warmth. The body relaxes. The muscles, tense from the day's cold, soften. The breathing slows. The mind quiets. The bed is not luxurious. It is not soft by the standards of modern comfort, but it is effective. It solves the problem it was designed to solve. It keeps the sleeper off the frozen ground, insulated from the cold air, and wrapped in layers that trap warmth. And in a place where the night temperature can kill an unprotected person, that effectiveness is not a minor achievement. It is survival. It is rest. It is the difference between waking refreshed and waking exhausted. The bed is where the family finds peace in the long winter night. The stove sits at the heart of the gyr. Not against a wall, not tucked into a corner, at the centre where its heat can reach all sides equally. The placement is deliberate. Heat radiates outward in all directions. A stove positioned off-centre would warm one side of the dwelling while leaving the other cold. By placing it in the middle, the family ensures that every sleeping area receives some warmth. However unequal the distribution might be, the stove itself is simple, a metal box, welded or riveted together from sheet iron or steel. The walls are thick enough to withstand repeated heating and cooling without warping. The base is flat and stable. The top is also flat, providing a surface for cooking. There is an opening at the front where fuel is added. This opening can be closed with a metal door, though many families leave it open during the coldest nights to maximise heat output. A closed door restricts airflow, which slows combustion and reduces heat. An open door allows more air to reach the fuel, increasing the burn rate and the warmth produced. At the back of the stove, a hole is cut for the chimney pipe. This pipe is usually made from thinner metal, sometimes salvaged from other sources. It rises vertically from the stove to the tonneau, passing through the centre of the roof. The pipe vents smoke and exhaust gases outside, preventing the interior from becoming filled with fumes. The pipe must fit snugly where it passes through the tonneau. Any gap would allow warm air to escape and cold air to enter. Traditionally, the gap is sealed with felt or clay. In modern gyrs, metal collars are sometimes used. The seal is checked regularly, especially after strong winds that might shift the pipe. The fire is built carefully. It is not simply a matter of throwing fuel into the stove and lighting it. There is a process refined by experience. First, the stove is cleared of ash from the previous fire. Ash accumulates quickly. If left in the stove, it insulates the base and reduces the efficiency of the burn. The ash is scooped out and disposed of outside, often scattered on the ground where it will eventually be absorbed. Then, kindling is arranged at the bottom of the stove. This might be dry grass, shredded bark, or small twigs. The kindling must be dry. Damp kindling will smoke and smoulder without catching flame. In winter, finding dry kindling can be challenging. Families often store a supply inside the gyr, where it stays dry and accessible. On top of the kindling, a few pieces of argil are placed. Not too many. The initial fire is small. Its purpose is to establish a base of heat, not to fill the stove. The argil is positioned so that air can flow between the pieces. Good airflow is essential for combustion. A flame is introduced. In the past, this was done with flint and steel, striking sparks into a nest of dry grass. Later, matches became common. Now, some families use lighters. The method varies, but the result is the same. A small flame touches the kindling and the fire begins. The kindling catches quickly. Flames lick upward, consuming the dry grass and twigs. The heat rises. The argil begins to warm. At first, the argil smokes heavily. The outer surface chars. Then, as the temperature increases, the argil begins to glow. The smoke lessens, the heat intensifies. More argil is added piece by piece. Each addition is timed. Add too much too quickly and the fire is smothered. Add too little and the fire dies back. The rhythm is learned through practice. A child watches their parent tending the fire, sees the timing, the spacing, the amount. Eventually they learn to do it themselves. As the fire grows, the interior of the gyr begins to warm. The change is not immediate. The felt walls have been cold for hours. They absorb some of the heat before they begin to radiate it back. The wooden frame absorbs heat. The air itself takes time to warm, but gradually the temperature rises. The area closest to the stove warms first. A person standing next to it can feel the heat on their face and hands. The rest of the gyr remains cold. The family gathers near the stove, holding out their hands, turning to warm their backs. As the fire continues, the warmth spreads. Convection currents begin to form. Warm air rises from the stove, circulates along the underside of the roof, and descends along the walls. This creates a slow, gentle circulation that distributes heat throughout the space. The felt walls, once cold to the touch, become neutral. They no longer draw heat away from the body. Eventually they may even feel slightly warm, though they never become hot. The felt is too thick, and too much heat is lost to the exterior for the inner surface to reach a high temperature. The floor remains the coldest part of the gyre. Cold air sinks. No amount of fire will make the floor as warm as the upper air. This is why the beds are raised. This is why felt mats cover the ground. The floor is a zone to be avoided when possible. During the day, the fire is tended regularly. Someone is always awake. Fuel is added as needed. The fire is kept at a moderate level, enough to provide warmth and to heat water for tea, but not so intense that it consumes fuel wastefully. Cooking is done on the stove top. A pot of water might simmer there all day. Milk tea is prepared and kept warm. Meat is boiled. The flat surface of the stove is hot enough to toast bread or warm leftover food. The fire also provides light. In the winter, daylight is brief. By mid-afternoon, the sun is low. By early evening, it is dark. The glow of the fire becomes the primary source of light inside the gyre. It is not bright. It does not illuminate the far corners, but it is enough to see by, enough to move around without stumbling. As night approaches, the family prepares for sleep. The fire is built up. This is the critical moment. The goal is to create a large mass of glowing fuel that will radiate heat for as long as possible. The stove is packed full. Argol is stacked carefully, with spaces for air to circulate. The fire is allowed to burn intensely for a time, heating the metal of the stove until it glows dull red. The heat radiating from the stove is fierce. The air around it shimmers. Then once the stove is fully loaded and the fire is established, the family begins to settle into their beds. They move away from the centre toward the edges, wrapping themselves in blankets and animal skins. The fire continues to burn. The heat continues to radiate. The interior of the gyre, which had been merely cool, becomes warm. For a time, it may even become hot. People shed blankets. They shift position, seeking a cooler spot. But the fire does not last indefinitely. Argol burns down. The glow fades. The heat diminishes. Within 2 or 3 hours, the fire is reduced to embers. The stove is no longer radiating intense heat. It is warm, but not hot. The temperature inside the gyre begins to drop, slowly at first, then more noticeably. The felt walls, which had absorbed warmth, begin to release it to the cold exterior. The air cools, breath becomes visible. The warmth that filled the space an hour ago is now a memory. This is when the fire must be tended. Someone must wake. Someone must rise from the warmth of their bed, cross the cold floor, and add fuel to the stove. It is not a pleasant task. The gyre is dark. The air is cold. The sleeper is warm under their blankets. But it is necessary. Without this intervention, the fire will die completely. The interior will become as cold as the exterior. Sleep will become difficult. The family will wake shivering. So the designated person rises. They move quietly, trying not to disturb the others. They crouch by the stove and open the door. Inside, embers glow faintly. They add argol piece by piece, positioning it carefully. They blow gently on the embers, coaxing them into flame. The fuel catches. The fire grows. The stove begins to warm again. The person waits until the fire is stable, then returns to bed. The entire process takes only a few minutes, but in those minutes, the continuity of warmth is maintained. This pattern repeats through the night. The fire is tended 2 or 3 times, depending on the cold and the quality of the fuel. Each time, someone rises. Each time, the fire is fed. Each time, warmth is restored. The tending is not resented. It is not seen as a burden. It is part of the structure of winter nights. It is as expected as the cold itself. The family knows that sleep in winter is not uninterrupted. It is segmented, punctuated by these brief awakenings, and in a way, the rhythm is calming. The knowledge that the fire will be tended, that the warmth will be maintained, allows for deeper rest in the intervals between. There is no anxiety, no fear that the cold will creep in unnoticed. The system is reliable. It has been tested. The fire is the centre. It is the source. Without it, all the felt and all the careful construction would be meaningless. The gyre would be a cold shell. The fire makes it a home. At the top of the gyre, the tonneau opens to the sky. This circular opening is both a necessity and a vulnerability. It must be there. The stove burns fuel. Combustion produces smoke and carbon monoxide and other gases. These must escape. Without the tonneau, the interior would fill with smoke, making it unbreathable. The occupants would suffocate or be poisoned, so the tonneau is left open. The chimney pipe rises through it. The smoke flows up and out. The air inside remains clear. But the tonneau is also an opening through which heat escapes. Warm air rises. It flows naturally toward the highest point in the gyre. At the tonneau, it exits. This is a constant loss. Heat is being generated by the stove and immediately lost through the crown. The challenge is to balance ventilation with heat retention. The opening must be large enough to vent smoke, but not so large that all the warmth is lost. The size of the tonneau is standardized, refined over centuries. It is large enough, but no larger. The yurk is the adjustable element. This is a square piece of felt attached to the tonneau by a rope. The rope hangs down into the interior of the gyre. By pulling the rope, the occupants can slide the yurk across the opening, reducing its size. On cold nights, when the fire is burning well and the smoke is minimal, the yurk is pulled partially closed. This reduces the opening to perhaps half its full size. Less warm air escapes. The interior retains more heat. If the fire is smoky, the yurk is pulled open. Smoke must be vented even at the cost of heat loss. A smoky interior is intolerable. Eyes water. Throats burn. Breathing becomes difficult. No amount of warmth is worth that discomfort. The management of the yurk is a skill. It requires judgment. Too closed, and smoke builds up. Too open, and heat is wasted. The person tending the fire also monitors the yurk, adjusting it as needed throughout the night. The yurk also serves a symbolic function. It is the lid of the gyre. When it is fully closed, the dwelling is sealed. This is rare. It might happen in a severe storm when wind-driven snow is pouring through the opening. But even then, the closure is temporary. The stove cannot burn without ventilation. Carbon monoxide would accumulate. During the day, the yurk is usually fully open. Light enters through the tonneau, illuminating the interior. The light is diffuse, filtered, through the felt edges of the opening, but it is enough to see by. On a clear day, a shaft of sunlight might angle through the tonneau, moving across the interior as the sun tracks across the sky. At night, the tonneau frames the stars. The occupants, lying in their beds, can look up and see the sky. The stars are visible through the opening, bright and unblinking in the clear, cold air. The constellations turn slowly overhead. This view of the sky is important. It is a connection to the outside world. The gyre is enclosed, but it is not sealed off. The sky is present. The vastness is present. The occupants are reminded that they are part of something larger. The tonneau is also the point where the roof poles converge. These poles radiate outward like the spokes of a wheel. The tonneau is the hub. It is the structural anchor. The poles transfer the weight of the roof, the felt layers, the snow, the wind pressure, down to the walls and ultimately to the ground. The tonneau itself is a work of craftsmanship. It is carved from a single piece of wood or assembled from multiple pieces joined together. The shape is circular, with a diameter of about 1 metre. The rim is thick and reinforced. Around the rim, sockets are carved at regular intervals. Each socket holds the end of a roof pole. The number of sockets must match the number of poles. In a typical gyre, this might be 80 or more. Each pole must fit snugly. A loose pole can shift, creating instability. A pole that is too tight can split the rim. The tonneau is heavy. It is supported by the two bagana, the vertical pillars that stand inside the gyre. These pillars are positioned symmetrically, one on each side of the stove. The top of each pillar is carved to fit the underside of the tonneau. The weight rests on the pillars, which transfer it to the ground. Without the pillars, the tonneau would sag. The roof poles would bend. The structure would weaken. The pillars are essential not just for stability but for maintaining the proper shape of the dome. In smaller gyres, the pillars might be omitted. The tonneau is lighter, and the roof poles can support it without additional help. But in larger gyres, the pillars are always present. The tonneau is painted in some gyres, decorated in others. Traditionally, it might be left plain. the natural wood simply oiled to protect it from moisture. In modern yurts, some families paint the tonneau in bright colours, red, blue, green, adding a touch of decoration to the otherwise utilitarian structure. When the yurt is disassembled for moving, the tonneau is carefully handled. It is one of the few parts that cannot be folded or collapsed. It must be carried whole. It is wrapped in felt to protect it and strapped to the back of a pack animal. The loss of the tonneau would be a serious problem. Without it, the yurt cannot be erected. The roof would have no central anchor. The family would have to find or carve a replacement, a task that requires time and skill. So the tonneau is guarded. It is treated with respect. It is more than a structural component. It is a symbol. In Mongolian culture, the tonneau represents the cosmos, the opening through which the spirits of the ancestors can look down on the family. It is the connection between earth and sky, between the human and the divine. At night, when the family sleeps, the tonneau is above them. The smoke from the fire rises through it. The cold air flows down through it. The stars shine through it. It is open. It is always open. And in that openness there is both loss and gain. Heat escapes, but the air remains clear. The cold enters, but so does the light. The tonneau is the crown, and like a crown it is both a burden and an honour. It completes the structure. It defines the space. It makes the yurt what it is. Without the tonneau there would be no yurt, only a pile of wood and felt. The tonneau is the piece that transforms materials into a dwelling. It is the opening that makes enclosure possible. Night on the steppe does not. Arrive gradually. The sun sets, and darkness follows quickly. There is no long twilight. The temperature, which may have been merely cold during the day, begins to plummet. Inside the yurt, the family knows the routine. They have lived through this night before hundreds of times. They know what is coming. As darkness settles, the last tasks of the day are completed. Livestock are checked. Water is brought inside if any is available. The argle pile is inspected to ensure there is enough fuel within reach. The door is secured, then the fire is built. This is the evening fire, the one that will carry the family through the first hours of sleep. It is built larger than the daytime fires. The stove is packed full. The argle is stacked carefully with attention to airflow. The goal is to create a sustained, steady burn. The family gathers near the stove. They sit on the beds, wrapped in blankets, drinking tea. Conversation is quiet, the day's work is done, there is nothing urgent to. There. Discuss. The talk drifts. Observations about the weather, the condition of the animals, small plans for tomorrow. Children may still be active, playing quietly in their sleeping areas, but gradually they are called to bed. The youngest first. They are settled under the blankets, positioned near their mothers. Their restlessness fades. Their breathing slows. The fire burns brightly. The interior of the yurt is warm, almost hot. The felt walls, which were cold earlier, now radiate a gentle warmth back into the space. The metal of the stove glows faintly. The chimney pipe hums with the updraft. One by one, the adults retire. They move to their sleeping areas. They arrange their blankets, check their positions, settle in. The last person to bed is usually the one who will wake first to tend the fire. They know their task. They accept it. The interior grows quiet. The only sounds are the crackle of the fire and the occasional shift of a body under blankets. Outside, the wind may be blowing. Inside, the air is still. The warmth from the fire is at its peak. Under the blankets, the heat becomes almost oppressive. A person might push a blanket aside seeking cooler air. The body, which has been cold all day, now radiates its own warmth. Sleep comes easily in this state. But the fire is already beginning to fade. The argle burns down. The glow diminishes. The heat output decreases. This process takes 2 to 3 hours, sometimes longer if the fuel was dense and well packed. The warmth inside the yurt begins to decline. It is not sudden. It is gradual. The felt walls stop radiating warmth and begin to conduct heat outward to the cold exterior. The air temperature drops. The metal of the stove, which was too hot to touch, becomes merely warm. At some point, usually in the deep middle of the night, the temperature crosses a threshold. It is no longer warm, it is cool. Breath becomes visible. The blankets, which were pushed aside earlier, are now pulled close. This is when the first person wakes. It might be by intention, a mental alarm developed over years of practice, or it might be the cold itself that wakes them, a subtle discomfort that pulls them from sleep. They lie still for a moment, assessing. How cold is it? How low has the fire burned? Is it time to add fuel, or can it wait a little longer? The decision is made. They rise. The transition from the warmth of the blankets to the cold air is sharp. They move quickly, minimizing exposure. Their feet touch the felt mats on the floor. The floor is cold, but not as cold as it could be. The felt provides some insulation. They cross to the stove. In the darkness, they navigate by memory. The layout of the gyr is known. There are no obstacles. They reach the stove and crouch beside it. The stove is still warm, but the fire inside is reduced to embers. They open the door. A faint glow is visible. They add argol piece by piece. The embers are disturbed and a small flame appears. The new fuel begins to catch. They wait, watching. The fire must be stable before they can return to bed. If they leave too soon, the fuel might not catch fully and the fire will die. They blow gently on the embers, encouraging the flame. The argol begins to glow. The fire is re-established. The stove begins to warm. They close the door or leave it open depending on the need for heat. Then they return to their bed. The crossing back is just as cold as the crossing out. They slip under the blankets, pulling them tight. Their body is cold now, cooled by the exposure, but the blankets trap their remaining warmth. Within minutes they are warm again. They settle, they sleep. This pattern repeats. The fire burns for a few hours, the gyr warms. The fire fades, the gyr cools. Someone wakes. The fire is tended. Warmth is restored. The rhythm is not disruptive. It is expected. The sleep is not continuous, but it is deep in the intervals. The body adapts to this pattern. Sleep comes quickly after each, waking. The interruptions are brief. For some families, the task rotates. One person takes the first shift, another takes the second. By distributing the responsibility, no single person bears the full burden of the night. For other families, one person takes on the role consistently, night after night. This might be the head of the household, or the eldest son, or whoever is most resilient to the cold. Children are rarely asked to tend the fire. The task requires getting up in the cold, handling the fuel, managing the stove. It is adult work. Children sleep through the night, undisturbed, protected by the vigilance of their parents. The rhythm of the night is not just about fire, it is about trust. The family trusts that the fire will be tended. They trust that the warmth will be maintained. This trust allows them to sleep deeply, knowing that the system will not fail. There is also a meditative quality to the task. The person who wakes does not rush. They move slowly, quietly. They tend the fire with care, not as a chore but as a responsibility. There is a satisfaction in it. The small flame growing, the warmth returning, the knowledge that the family is safe. In the deep hours before dawn, the gyr is silent except for the sound of breathing and the occasional crackle of the fire. Outside, the temperature may have dropped to its lowest point. Inside, the warmth holds. The felt walls stand between the family and the killing cold. The stars turn overhead, visible through the tonneau. The moon, if it is present, casts a faint light through the opening. The interior is not completely dark. There is a dim glow from the stove, a faint illumination from the sky. The night passes, hour by hour, tending by tending. The fire burns, fades, is renewed. The family sleeps, wakes, sleeps again. And then, gradually, the darkness begins to thin. The stars fade. The sky through the tonneau shifts from black to deep blue to pale grey. Dawn is coming. The last person to tend the fire wakes to this changing light. They add fuel one more time, building the morning fire. This fire will carry the family into the day. It will heat water for tea. It will warm the interior as people rise and begin their routines. The night is over. The family has survived it. They have slept. They have rested. They are ready to begin again. The gyr is small. A typical family dwelling is perhaps 5 meters in diameter. The interior space is limited. There are no separate rooms. Everyone sleeps in the same circular area. This closeness is not accidental. It is a strategy. A human body generates heat. Even at rest, even during sleep, the body is burning calories and producing warmth. This warmth radiates outward into the surrounding air. In a cold environment, this heat is lost. It dissipates into the larger volume of cold air. But when multiple bodies are close together, the heat does not dissipate as quickly. The warm air produced by one body mingles with the warm air produced by another. The space between them becomes warmer than the surrounding air. This is social thermoregulation, the sharing of body heat to maintain a stable temperature. In the GR, this happens naturally. The sleeping areas are arranged around the perimeter, but they are not far apart. A family of 5 or 6 people might occupy a space that, in another culture, would be considered cramped. But here, the closeness is functional. Parents sleep near each other. Children sleep nearby, sometimes in the same bed, sometimes on adjacent platforms. The beds are pushed close to the walls, and the walls themselves provide some small amount of reflected warmth. But the primary source of shared warmth is the proximity of the bodies themselves. Infants benefit most from this arrangement. An infant cannot regulate its own temperature effectively. The ratio of surface area to body mass is high. Heat is lost quickly. Without external warmth, an infant would become hypothermic in a cold environment. So, the infant sleeps next to the mother. Skin contact is common. The infant is swaddled in layers of cloth and sheepskin, but the swaddling is not so thick that it prevents warmth from passing between mother and child. The mother's body heat keeps the infant warm. The infant's presence close to the mother allows her to monitor breathing, to respond quickly if the child stirs or cries. This arrangement also facilitates feeding. In the night, if the infant wakes hungry, the mother does not need to rise, cross the cold gear, and retrieve the child from a distant cradle. The child is already there, within reach. Feeding happens without full waking. Both mother and child return to sleep quickly. Older children sleep together. Brothers and sisters lie side by side, sometimes 2 or 3 in a row. They share blankets. The youngest is positioned in the middle, where it is warmest. The older children on the edges are more exposed to the cooler air, but they are also more resilient. This clustering creates a microclimate. The air under the shared blankets is warmer than the air above. The combined body heat of the children raises the temperature by several degrees. The blankets trap this warmth. The children, even if they shift position during the night, remain within this warm pocket. Adults also benefit. Husbands and wives sleep close. Their combined warmth is greater than the warmth either could produce alone. The shared blankets create a thermal envelope. Movement is minimized. Each shift of position disturbs the warm air, allowing cold air to enter. So the sleepers lie still, maintaining the integrity of the warm space they have created. Elderly members of the family sleep in the koimor, the warmest part of the gear, but they also sleep near others. An elderly person might sleep near an adult child or grandchild. The presence of another body nearby provides warmth that the elder's own metabolism may no longer generate sufficiently. The elderly are often more vulnerable to cold. Their circulation is poorer, their metabolic rate is lower, they generate less heat. By positioning them in the warmest location and ensuring they are near others, the family compensates for this vulnerability. The shared warmth is not just physical, it is psychological. The presence of others nearby is reassuring. The sound of breathing, the slight movement of a body under blankets, the knowledge that one is not alone, all of this contributes to a sense of security. In a landscape where isolation can be deadly, where a person caught alone in a storm can freeze within hours, the proximity of family is a profound comfort. The gyr is not just a shelter from the cold, it is a gathering place, a point of connection. The closeness also has practical benefits. If someone becomes ill during the night, others are nearby to notice and respond. If a child has a nightmare, a parent is within arm's reach to comfort them. If the fire needs tending, someone is always close, enough to wake and take care of it. The arrangement is efficient. It maximizes the use of space. It minimizes the volume of air that must be heated. It allows the family to pool their resources, their body heat, their vigilance, their care for one another. But the closeness is not oppressive. The gyr is round. There are no corners where people are trapped. The space flows. Movement is possible. If someone needs to rise during the night, they can step over sleeping forms without disturbing them too much. The layout is known. Everyone understands where everyone else is sleeping. Privacy, as understood in other cultures, does not exist in the Gur. But privacy is not valued in the same way. What is valued is warmth, safety, and the presence of family. These are prioritized over individual space. The shared warmth also reflects a deeper principle of nomadic life. Survival depends on cooperation. A single person, alone on the steppe, cannot survive a winter. A family, working together, can. The gyr is the physical manifestation of this principle. It is designed for collective living, for shared effort, for mutual support. At night, this cooperation takes the form of shared body heat. It is passive. No one needs to make a conscious effort. Simply by sleeping near each other, the family creates a warmer environment for all, and in the morning, when they wake, they rise from this shared warmth together. They face the cold day together. They move through the routines of feeding animals, collecting fuel, preparing food, and at night they return to the gyr, to the shared space, to the warmth they create together. The gyr is a small circle, but within it, the family is complete. The cold requires energy. The body must work to maintain its core temperature. This work burns calories. In a warm environment, the body can function on a moderate diet. In a cold environment, the caloric needs increase sharply. The traditional Mongolian winter diet reflects this reality. It is heavy. It is rich in fats and proteins. It is designed to fuel the body's internal furnace. Meat is the foundation, mutton primarily. Sheep are the most common livestock on the steppe. They are hardy, adaptable, and numerous. In winter, when milk production declines and grazing is poor, sheep are slaughtered for meat. The meat is boiled, roasted, or dried. It is eaten in large quantities. A typical meal might consist of boiled mutton served with broth. The meat is fatty. The fat is not trimmed away. It is consumed deliberately. Fat is calorie-dense. 1 gram of fat provides 9 calories, more than twice the energy of 1 gram of carbohydrate or protein. In a cold environment, this density is essential. The fat is also warming. Digesting fat generates heat through a process called thermogenesis. The body breaks down the fat molecules, releasing energy. Some of this energy is used for cellular processes. Some of it is released as heat. This heat warms the body from the inside. The effect is noticeable. After a meal of fatty meat, a person feels warmer. The sensation is not imaginary. The metabolic rate increases. Blood flow increases. The skin may flush slightly. This internal warmth supplements the external warmth from the fire and the blankets. Traditional Mongolian medicine recognizes this. The medical system divides foods and conditions into categories based on their thermal qualities. There are hot foods and cold foods. In winter, when the external environment is cold, hot foods are prescribed. Meat is considered a hot food. So is fat. Butter and milk fat are consumed in tea. The tea itself is made from boiled water, milk, and salt. It is drunk throughout the day, hot and rich. The fat in the milk provides calories. The heat of the liquid warms the throat and stomach. Carbohydrates are less prominent in the winter diet. Grain is not grown on the steppe. Flour must be traded for or purchased. It is used sparingly. Bread is made, but it is not the staple. It is in agricultural societies. Meals are centered on meat, not grain. Vegetables are rare in winter. The growing season is short. By the time winter arrives, any stored vegetables are long gone. The diet is almost entirely animal-based. Meat, fat, milk, and occasionally yogurt or cheese. There is little variety, but variety is not the goal. The goal is caloric density and warmth. The body adapts to this diet. Over generations, the metabolism of steppe nomads has adjusted to high-fat, high-protein intake. Digestive systems process meat and fat efficiently. The gut microbiome is different from that of populations that consume more plant-based diets. Research has shown that Mongolian pastoral nomads often develop a central fat distribution. Fat accumulates around the abdomen rather than being distributed evenly. This abdominal fat is metabolically active. It generates heat. It serves as an energy reserve. During the winter, when physical activity may be reduced but caloric needs remain high, this fat is drawn upon. The fat distribution is particularly pronounced in women and children. Women who may experience pregnancy and lactation need energy reserves to sustain these processes. Children, who are still growing and have higher surface area to mass ratios, benefit from the insulation and the energy reserve. This is not obesity, it is adaptation. The fat serves a function. It is not excess. It is a necessary component of survival. The diet also includes bone marrow. When an animal is slaughtered, nothing is wasted. The bones are cracked open and the marrow is extracted. Marrow is rich in fat and nutrients. It is eaten directly or added to soups. It is considered a delicacy, particularly for children and the elderly. Organ meats are consumed as well. The liver, heart, kidneys, all are used. These organs are nutrient-dense, providing vitamins and minerals that are scarce in a meat-only diet. The liver in particular is rich in vitamin A and iron. In a diet that includes little plant material, these nutrients are critical. Salt is added to most foods. Salt is necessary for maintaining electrolyte balance, particularly in a cold environment where dehydration can occur without obvious sweating. Salt is also a preservative. Meat preserved with salt can be stored for extended periods, providing food security through the winter. The timing of meals also matters. A large meal in the evening before sleep provides fuel for the night. The body metabolizes the food slowly. The heat generated continues for hours, warming the sleeper from within. This is why the evening meal is often the largest and the richest. In the morning, a lighter meal is consumed. Tea, perhaps some leftover meat, maybe a small piece of bread. The morning is for activity, tending animals, collecting fuel, managing the gyre. The body is moving, generating its own heat through work. The need for dietary thermogenesis is lower, but as the day progresses and the temperature drops, another meal is eaten, and then, as night approaches, the large evening meal. The cycle repeats. The diet is not varied, it is not colourful, it does not include the fruits, vegetables and grains that are common in other cuisines, but it is effective. It provides the calories needed to survive, it generates the warmth needed to sleep, and it is sustainable. The animals that provide the meat are raised on the steppe, fed by the grass that grows naturally. There is no dependence on external supply chains. The system is self-contained. The body, fueled by this diet, becomes a furnace. It burns the fat and protein, producing heat and energy. At night, wrapped in blankets, the body continues this process. The metabolic fire burns low but steady. The sleeper remains warm, even as the external temperature plummets. The diet is not comfortable. It is not a diet one would choose for pleasure. But it is a diet chosen for survival. And in that context, it succeeds. It keeps the body warm, it keeps the body alive. And in the morning, the person wakes, ready to face another cold day. The newest members of the family face the greatest challenge. An infant has not yet developed the ability to regulate temperature efficiently. The systems that control heat production and heat loss are immature. The body is small, the skin thin, the layer of insulating fat minimal. In a warm climate, this vulnerability is manageable. In a climate where the interior temperature can swing from 25 degrees Celsius to near freezing in a matter of hours, it becomes critical. The traditional response is swaddling. The infant is wrapped tightly in layers of cloth. Cotton is used for the inner layers, soft against the skin. Over this, wool is added. Then sheepskin, with the fur facing inward. The wrapping is snug, immobilizing the arms and legs. Only the face is exposed. This practice is ancient. It appears in descriptions of nomadic life going back centuries. It is not done for convenience or tradition alone. It serves a thermal function. The tight wrapping reduces the surface area from which heat can be lost. An unwrapped infant with arms and legs extended loses heat from every exposed surface. A swaddled infant presents a more compact form. The outer layers trap air close to the body. This air is warmed by the infant's metabolism and held in place by the wrapping. The sheepskin is particularly important. The wool fibres create thousands of tiny air pockets. Air is a poor conductor of heat. These pockets form a barrier that slows the transfer of warmth from the infant to the cold environment. The fur also wicks moisture away from the skin, preventing dampness that would accelerate heat loss. The swaddled infant is placed in the sleeping area, close to the mother. Often the infant sleeps directly beside her, within the same set of blankets. The mother's body provides additional warmth. Her presence also allows her to monitor the infant continuously. If the wrapping comes loose, she can adjust it. If the infant becomes too warm, she can loosen a layer. Temperature regulation in infants is delicate. Too cold, and the infant's core temperature drops. The body's response is to constrict blood vessels in the extremities, preserving warmth for vital organs. But this response is imperfect in very young infants. Prolonged cold can lead to hypothermia, even if the core temperature does not drop dramatically. Too warm, and the infant overheats. Infants cannot remove their own coverings. They cannot move away from a heat source. Overheating can lead to dehydration and distress. The swaddling must be adjusted as the temperature in the gyre fluctuates. Research conducted in gyres has measured these fluctuations. In winter, the interior temperature can vary by more than 20 degrees over the course of a night. Just after the fire is built, the temperature might reach 25 degrees. By the early morning hours, before the fire is tended again, it might drop to near zero. Despite this variation, swaddled infants maintain stable core temperatures. The measurements show that the infant's body temperature remains within the normal range, even as the ambient temperature swings wildly. The swaddling, combined with proximity to the mother, creates a microenvironment that buffers the infant from the larger fluctuations. Interestingly, infants raised in gyres develop certain physiological patterns earlier than infants raised in centrally heated apartments. One pattern is the diurnal variation in core temperature. In adults, core temperature naturally falls during sleep and rises during waking hours. This rhythm is part of the circadian system. In most infants, this pattern does not fully develop until several months of age. But in gyre-raised infants, the pattern appears earlier. The core temperature drops at night and rises during the day, even in very young babies. The peripheral temperature, measured at the skin surface, shows the opposite pattern, rising during sleep as blood flow to the extremities is maintained. This early maturation suggests that exposure to temperature variation may stimulate the development of thermoregulatory systems. The infant's body learns to respond to the environment more quickly. The metabolism becomes more efficient. The blood vessels learn to constrict and dilate in response to thermal cues. This is not stress. It is adaptation. The infant is not suffering. The body is simply learning to function in the environment it inhabits. And that environment, while challenging, is not beyond the infant's capacity to adapt. Feeding also plays a role. Infants are breastfed frequently. Breast milk provides not only nutrition but also warmth. The act of feeding brings the infant into close contact with the mother. The mother's body heat surrounds the infant. The warm milk fills the stomach, providing internal warmth. Nighttime feedings are common. The infant wakes, cries softly, and the mother responds without fully waking. The infant is brought to the breast. Feeding happens in the darkness under the blankets. When the infant is satisfied, both mother and child return to sleep. The entire interaction takes only a few minutes, and the warmth of the shared bed is maintained throughout. The frequent feedings also support the infant's metabolism. The calories from the milk are converted to energy. Some of that energy is used for growth. Some is released as heat. The infant, though small, is generating warmth continuously. The swaddling and the mother's presence ensure that this warmth is not lost. As the infant grows, the swaddling is gradually loosened. By 6 months, the child may wear fewer layers. By a year, the child is dressed in small wool garments rather than being wrapped. The body has matured. The thermoregulatory systems are more developed. The child can tolerate greater variation. But even as the child grows, the principle remains the same. The child sleeps close to family members. The child is dressed in layers. The child is positioned in the warmer parts of the gyre. The strategies that protected the infant continue to protect the child, adapted to the child's increasing resilience. Children raised in this way develop a tolerance for cold that seems remarkable to outsiders. They play outside in temperatures that would seem unbearable. They sleep under fewer blankets than adults might expect. Their bodies have learned from infancy to function in a cold environment. This learning is not conscious. It is physiological. The metabolism adjusts, the circulation adjusts, the body becomes efficient at conserving heat and generating warmth, and this efficiency, developed in childhood, persists into adulthood. The infant in the gyre is vulnerable, but the infant is not abandoned to that vulnerability. Every aspect of care, the swaddling, the positioning, the feeding, the monitoring, is designed to protect. The knowledge of how to care for an infant in extreme cold is part of the culture. It is passed from mother to daughter, from grandmother to mother. It is tested every winter with every new child. And it works. Infants survive. They thrive. They grow into children, then adults, then elders. And when they have children of their own, they know how to care for them. The cycle continues. The knowledge endures. Sleep is not just a physiological state. It is an experience shaped by the senses. What we see, hear, smell, and feel as we drift towards sleep affects the quality of rest. In the gyre, the sensory environment is distinct. It is unlike sleep in a modern house or apartment. The sounds are different. The smells are different. The visual field is different. These differences create a particular quality of rest, one that has been described by those who experience it as deeply calming. Sound is the first element. The steppe is quiet. There are no cars, no sirens, no voices from neighbouring buildings. The nearest other dwelling might be kilometres away. The silence is profound, but it is not absolute silence. There is the wind. The wind on the steppe is constant in winter. It moves across the grassland without interruption. When it reaches the gyre, it presses against the felt walls. The felt absorbs some of the sound, but not all. What remains is a low, steady whisper. It is not loud. It does not vary much. It is simply there, a constant presence. This sound is not disturbing. It is predictable. The brain, after a few nights, learns to filter it out. It becomes background, like the sound of a distant stream or the rustle of leaves. It does not wake the sleeper. It does not intrude on dreams. Inside the gyre there are other sounds. The fire in the stove crackles softly. Argel does not burn with the sharp snap of wood. It glows and smoulders. Occasionally a pocket of moisture will expand and produce a small pop. Occasionally a piece of fuel will shift as it burns down. These sounds are irregular, but they are gentle. They do not startle. There is also the sound of breathing. Multiple people sleeping in a small space create a rhythm of inhalation and exhalation. The sounds overlap. They are soft, almost inaudible individually, but together they form a kind of ambient presence. It is the sound of life, of presence, of not being alone. If someone stirs in their sleep, the felt mats rustle slightly. If someone adjusts a blanket, there is a soft movement of fabric. These sounds are minor. They blend into the overall quietness. They do not break the stillness. The acoustic properties of the felt walls contribute to this quietness. Felt is dense. It absorbs sound waves rather than reflecting them. A shout inside a gyre does not echo. A conversation does not carry to the far side of the space with the sharpness it would in a hard-walled room. The felt dampens everything, creating a muffled, enclosed quality. This dampening extends to sounds from outside. The bleat of a sheep, the distant howl of a wolf. These might be audible, but they are softened. They reach the interior as faint, indistinct noises. The gyre creates a buffer between the sleeper and the world outside. Smell is another defining element. The gyre has a particular scent, one that is immediately recognisable to anyone who has spent time in one. The primary smell is argel. Burning dung has a distinct odour. It is earthy, organic, not unpleasant to those accustomed to it. It does not smell like wood smoke, which is sharp and resinous. Argel smoke is softer, more neutral. It carries a hint of grass, of the steppe itself. This smell permeates the felt. The felt absorbs the smoke over months and years. Even when the fire is out, the scent lingers. It is the smell of warmth. To someone raised in a gyre, it is the smell of home. There is also the smell of wool. The felt, the blankets, the sheepskins, all carry the scent of lanolin and animal fibre. It is a clean smell, slightly oily, unmistakably organic. It mixes with the smoke to create a compound scent that defines the interior. If food has been cooked recently, there may be the smell of boiled meat or milk tea. These scents fade quickly in the cold air, but they add to the overall olfactory landscape. The smells are never strong. They are background, but they are consistent and they signal safety. Familiar smells tell the brain that the environment is known, that there is no threat. The visual environment at night is simple. When the fire is burning, there is a faint glow from the stove. The metal surface might emit a dull red light. This is not bright enough to illuminate the entire gyre, but it is enough to see shapes. The outline of a person under blankets, the curve of the lattice wall, the vertical line of the bagana pillars. When the fire dies down, the only light comes from outside. If the moon is visible, its light filters through the tonneau. The opening at the crown is small, but on a clear night, moonlight can cast a faint glow into the interior. Objects are not clearly visible, but there is a sense of space, a recognition of depth. On nights when there is no moon, or when the tonneau is partially covered by the yurt, the interior is completely dark. The darkness is total. There is no light pollution, no ambient glow. The darkness is so complete that it can feel almost tangible. But this darkness is not frightening. It is expected. The sleepers know the space. They know where everyone is positioned. They know the layout. The darkness does not disorient them. It is simply the absence of light, nothing more. The stars, when visible through the tonneau, provide a focal point. Looking up from the sleeping position, the occupant can see a circle of sky. The stars are brilliant in the clear, unpolluted air. They do not twinkle as much as they do in more humid climates. They shine steadily, white and cold. The constellations turn slowly overhead. For someone familiar with the sky, this turning is a clock. The position of the stars indicates the hour. The rotation is slow, almost imperceptible, but over the course of a night it is significant. The stars that were to the east earlier in the night are now overhead. Those that were overhead are now to the west. This connection to the sky is part of the experience of sleeping in a gyre. The dwelling is enclosed, but it is not sealed. The sky is present. The cosmos is present. The sleeper is reminded, without words, that they are part of a larger order. Touch completes the sensory landscape. The textures inside the gyre are all natural. Wool, felt, leather, wood. There are no synthetic fabrics, no plastic, no metal, except for the stove. The wool against the skin is soft but slightly coarse. It has texture. It is not the smooth, uniform softness of processed textiles. It is irregular, alive with the character of the animal it came from. The felt under the body is firm. It does not compress easily. It provides support. Lying on it is not like lying on a soft mattress. It is more like lying on a padded floor. The body is held, not cradled. The blankets have weight. They press down. This weight is comforting. It provides a sense of being anchored, of being held in place. The body does not feel adrift. It feels secure. The air against the face is cool. Even with the fire burning, the air in the gyre is not uniformly warm. The warmth is concentrated near the stove and under the blankets. The air in the open space is cooler. Breathing this cool air is refreshing. It does not feel stifling or oppressive. All of these sensory elements combine to create a particular quality of sleep. The sounds are steady and soft. The smells are familiar and reassuring. The light is dim or absent. The textures are natural and grounding. The brain, receiving these consistent signals night after night, learns to associate them with rest. The sensory environment becomes a cue. When the wind begins to whisper against the felt, when the smell of argle fills the air, when the stars appear through the tonneau, the body knows it is time to sleep. And sleep comes, not always immediately, not always without interruption, but it comes, deep and restorative, carried by the rhythms of the steppe, the warmth of the fire and the presence of family.